part is a right prism with an equilateral triangle. This is how it is, and this is how it is. This is a right prism, and in this there are going to be 4 planes of symmetry. This is the first one, from the center of this side to the opposite vertex. This is one. In the same way, one will be in this direction like this, and one more will be in this direction like this, and then these are 3 planes of symmetry. These are 3 planes of symmetry, from this vertex to this side, then from this vertex to this side, then from this vertex to this side, and then comes the last one. The last plane of symmetry will be this. I hope you can see this is right there in the middle, in the center. I really hope you can see that. So these are 4 planes of symmetry in the case of a right prism with an equilateral triangle as the base. Then comes a right pentagonal prism. A right pentagonal prism has 6 planes of symmetry. The first one is going to be the one which actually bisects the prism like this. This is the first one. This is the first one. I hope you can see it through. This is the first one. This is one, and then the rest of the 5s will be like this, from one vertex to the center of the opposite side. This is how it is, if you can see. Okay, so from this vertex to the midpoint of this side, in the same way from this vertex to this vertex to this to this, and then this vertex to this side. So there will be 6 planes of symmetry in the case of a right pentagonal prism. Then comes one of the most difficult one, tetrahedron. This is a tetrahedron, and in this the first plane of symmetry is going to be like this. This is the first plane of symmetry, and yes, this is the first plane of symmetry. From the center of this surface to this edge, this one, and in the same way, this is the first one, from this edge to the center of this surface, then from this edge to the center of this surface, and at the same time from this edge to the center of this surface. These are 3, and then there are 3 more. This might disturb you the most, but there will be one more, and that will be in this direction. Okay, we used the top vertex and had 3 planes of symmetry. Now we are using this edge, and we have one more plane of symmetry, and then we will do it like this, and this will appear in this form. This will be one more plane of symmetry, and then we will do it for this one, and this will look like this. So a very quick recall. This was the first one for the top. This was the first one for the top vertex in this direction, and for the top vertex one will enter from here and appear at this edge. The third one will enter from this side and touch this edge. These will be 3 for the top, and then there will be one more that will enter in this way and touch this side. 1, then 2, and then in the same way 3, the one which I showed you by rotating it. This is 1, it will appear like this. Okay, this is one more, then second, and then third. I hope that 6 planes of symmetry in the case of irregular tetrahedrons are clear. Then comes this shape, a cone. In a cone there are infinite planes of symmetry. You can just insert a triangle like this, and it will have infinite planes of symmetry in a cone. The same thing goes with a cylinder, infinite planes of symmetry, a hemisphere, infinite pairs of symmetry, and for a sphere as well, infinite pairs of symmetry. And for this, a square pyramid, in the case of a square pyramid, there are 4 planes of symmetry which I have discussed already in my previous video, and I hope all the planes of symmetry are clear. And one last thing that I would like to discuss: axis of rotational symmetry and axis of rotational symmetry in case of a square, in case of a cube. I'm sorry, this is a cube already designed to have axis of rotational symmetry, and in this case, I'll just give me a minute. Yes, okay. For a cuboid, I have already told you the axis of rotational symmetry. Now I am going to discuss axis of rotational symmetry in a cube. And in the case of a cube, this might look the most difficult one. And the first plane of axis of symmetry will be from the center. Let me try. We hope it will survive. So, okay, very good. So the first axis of rotation, this is the first axis of rotation from the center of the bottom till the center of the top. First axis of rotation from the center of the bottom till the center of the top. In the same way, the second axis of rotation will be from the center of this surface to the center of the other surface. So this will be the second one. So I have one here, the second one will be like this, and the third one will be like this. So from one surface to another surface, there will be 3 axes of rotation. They were very easy. And then the next one, they will be from one vertex to the other vertex. I don't think this will be usable after this explanation, so that will be like this, from one corner, from one vertex to the other vertex, from this to this. In the same way, from this corner to the front corner, the next one will be from here till here, and then from here till here. These will be 4 more axes of symmetry. We have altogether 7 axes of symmetry up till now between the surfaces, then from one vertex to the other vertex, and then it comes from the midpoint of each edge. This is the edge, and from this edge, from the midpoint of this edge to the midpoint of the edge on the back side at the bottom. So one entering from the front top edge and touching the bottom edge at the back. This will be one. Then this will be one more from one edge to the other edge. So altogether we have 9. Then one will go from this edge and appear here. That will look like this. So from edge to edge we have 3 and we have 4 up till now. Okay. So 4 from edge to edge, there is one more edge remaining, and that edge is this, and then this. So from this edge to this, and in the same way from this edge to this edge. So altogether we have now 13 axes of rotation in the case of a cube. From one surface to the other surface we have 3, from one vertex to the other vertex we have 4, altogether they are 7, and then from one edge to the other edge, this 1, then 2, then 3, and then 4. These are 4 more, that makes it 11, and then 1 from here 12, and then 1 from here, that is 13. I hope these were the most difficult things which I have discussed. Hopefully this explanation will help you understand how to identify the axis of rotation and the planes of symmetry.